So, all right. Excuse me. Hi. Over here. Okay. You and a friend go to tacos galore for lunch. Uh, and I just really want to say tacos, 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 tacos. And if you know that joke, then you're gonna be like one in a million. There's a show, a really, really dumb show where one of the restaurants was called Tacos, 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 Tacos. But I feel like tacos galore is pretty close to tacos, 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 tacos. Why am I still saying it? Because it's fun to say. Okay, anyway, you order three soft tacos and three burritos, and your total bill is $11.25. Your friend's bill is $10 for four soft tacos and two burritos. How much do soft tacos cost? How much do burritos cost? Okay, so what I did was I took the two things they were asking for and I assigned those letters. I don't like to use S because it looks like a 5. It's just my thing. Okay, anyway, you order three tacos and three burritos, and your total bill is $11.25. So here's three tacos, three burritos, $11.25. Your friend's bill is $10, so I'm going to line that up underneath the money for four tacos and two burritos. All right. This is set up to do elimination method, and there's really not a great option here. I have to multiply both equations no matter what. So I'm just going to do the front ones because I'm lazy. So I'm going to multiply the top by -4 and the bottom by 3. Now, why would I choose one of them to be negative and one of them to be positive? Anybody know? Yeah, so I can add exactly. Problem is, I don't know what 4 times 11.25 is. Is it $45? It is? Oh, oh, I just made my own day. What did I not do? Oh, yeah. I got so excited about the 45, I didn't distribute. Yeah, I'm slightly less excited about the 45 now, but only slightly. Okay, 12t plus 6b equals 30. Alrighty-o. 12t's cancel. I have -6b equals -15. And you start to get a little nervous because you're like, oh no, it's not going to come out evenly, except you have to remember it's money. So you're not really expecting it to. It should be dollars and cents anyway. 15 divided by 6. Mrs. Talbot, what is happening on your calculator? That would be AP stats there. It's a binomial cumulative density function. Okay, anyway, so burritos are 250. Man, I need to go to tacos galore if burritos are actually 250. Just say. Okay, now we're gonna plug it in. So I'm just gonna plug it into the top one. Really no good option here. 3t plus 3, 250 equals 11.25. You can already do this without me. Oh, you can need me. 3 times 250, that's 750, right? Okay. Oh no. 375? No. 3, what? Is it? 3, I'm a genius right now. Man, Tacos Galore has the best prices in town. Either that or this problem was written like 47 years ago. I'm gonna go with the latter. Okay, any questions about tacos, 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 tacos? And Gio's like, what the heck? I mean, tacos, 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 and burritos. Oh, so I guess it should be tacos, 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 and burritos. But there should be like a dot, dot, dot pause. Yeah. Okay. Anyways, no, my own restaurant. No, nobody wants that. Okay. Oh, more food. You're running a concession stand at a basketball game. Look at you go. You're selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. How many hot dogs were sold? Okay, so that's the first thing I'm going to make a letter. And how many sodas were sold? Oh man, it's going to make me use the S, isn't it? Okay, so H equals hot dogs, S equals soda. You guys are just going to have to watch me carefully, make sure that I don't change any of those to five. Okay, this column is set up, worded very differently because it gave you the prices this time, and now you have to find out how many there are. Okay, so one of the equations is going to be just based on money. So each hot dog costs $1.50. So $1.50 per hot dog. No, so true. Plus soda is 50 cents. It's also Costco. And a total of $78.50. So this whole equation here is all about money. And then you think to yourself, Mrs. Talbot, you didn't give me enough information because there's only one number left over in the problem, except it told you that it was hot dogs and sodas combined. So hot dogs and sodas combined were 87. Okay. What should we do here? Do you want to multiply the bottom by negative 1.5? Is that what you would do? Or would you like subtract something and plug it in? Or you want to do substitution? Yes? Okay. Okay, so I got the S by itself in the second equation. And then I put it in parentheses and put a little arrow where I'm going to put it for substitution. It's a good idea. We review both methods this way anyway. Okay. So what's half of 87? 43.5? Yeah. Oh, that's convenient. $35. Anybody do this problem before me? 35? 35? Is it 35? 35 hot dogs. And that's 32? No, 52. So pretty. Okay, so today at the end, I'm going to try to stamp the warm up. So make the picture you got on. Take a look. And then If you're missing some that you want to do like tonight, it's fine. Just let me know when I come stay up. Does that make sense? Okay, so warm-up should be done. Now, if you guys could set this up, please. I just want to know, and this is just me being ridiculous as I am. You know me for being ridiculous. I made my XY axis in black because I'm going to graph the inverse in red and the original in blue, and if the axes are also blue, it sort of blends together. And it doesn't normally, it's just that these have asymptotes, so you got the dash line. But if you're doing everything in pencil, then you're fine. Great. Okay, so we're gonna do a lot on this problem. It's gonna take us a few minutes. The rest of this should go pretty quick. First thing you should notice is that my notes say graphs of logarithms, and that's not a logarithm. Yeah, I have an exponential there. But I know. But that's because I want to treat this like an inverse problem first. So I want to pretend that we have an inverse situation. And so that's why I want to do it this way. So we're gonna start this as an inverse. And we're going to like list some things under here. So first on this problem here, I don't actually want a dot there. I want to, actually, I can fix this. Hold on. A equals H equals K equals. Okay, and I'm going to grab my blue sheets for exponentials just to make sure that I've got what I need. So in this problem, A is in the front of the base. There's nothing there, so that's 1. H is the opposite sign of whatever's in the exponent, -1, and K is -2. Okay, why is that important? Well, following this, we can use that to find the locator point and the asymptote. So that means that there will be a horizontal asymptote, and I'm going to put HA at y equals K, y equals -2. Are you guys with me so far? So I identified A, H, and K, and then I identified the horizontal asymptote. Why do I want to do that first? Because I want to sketch that in. So come over here to your graph. Before I make the curve for the exponential, I want to sketch in my asymptote. Okay. Now I'm going to put my locator point in the middle of my table. So I'm going to come back over here. Locator point for an exponential is h comma k plus a. So h comma, what's k plus a? Yep, -1, right? So 1 plus -2 is -1. Okay, and then I'm going to go 2 up, 2 down. Okay, I got to be honest with you. Might grab the calculator for the negative exponent part when we subtract the 2. We'll see. We'll see how we do here. Okay, let's go the positive direction. So 0 plus 1 is 1. 3 to the 1 is 3. 3 minus 2 is 1. That's not too bad. Not too bad. Okay. 1 plus 1 is 2. 3 to the 2 is 9. 9 minus 2, 7. Okay, okay, okay. We're doing it. Okay. -2 plus 1. -1. 3 to the -1. 1/3. Okay, this is the hard part. What's 1/3 minus 2? And I'm just going to do it on here just because it's -5/3. If you think about this being 1/3 and this being 6/3, 1/3 minus 6/3 is -5/3. But I don't actually care at this moment for us to review the 4th grade fractions. So we're just going to put -1.7 here. Now, when we get to sine and cosine waves, you will need to be able to find a common denominator in your head and subtract fractions, but not today. Okay, now, -3 plus 1, -2, 3 to the -2, 1/9. Nice. -1.9. Mrs. Talbot, if you're letting us use the calculator for the last little bit, why won't you let us just plug in the things in the calculator? Because I want to review the negative exponents again. Okay, anyway. So -1, -1, 0, 1, 7, -2, -1.7, 3.9. Okay, and before we finish this, we're going to do one more thing with the original, and that is find the domain and range. So take a look at the domain and range of the exponentials. Domain is all real numbers. And the range is, this is a positive A problem, so y is greater than k. I forgot my R. Okay. And it makes sense from the table. You can tell that the y's are greater than -2. Okay. We're actually not done with the original yet. We have to do one more thing. Do you know what it is? We could, but remembering this is an inverse problem, I want to do the steps. Okay, so this particular thing has 3 steps. Okay, if I plug something in for X, order of operations, what goes first? Add 1. And then what? I'll just say it, 3 to the power, and then minus 2. Okay, I think I'm completely done with the blue pen on this problem now. Okay, now if you're looking at your blue sheets, if you're following along, flip to the back where we did logarithms, because we all should know the inverse of an exponential is a logarithm. So we're going to use this page now. But first, we're going to undo the steps. So undo this first. How do we undo 3 to the power? Log base 3. And then minus what? Okay, we have to be careful when we write this, because we know this log base 3 is going to go in front of our x. It always lives in front. So I'm going to like leave some space, put my x over here. First step is to add 2. Second step is to log base 3 everything. And the third step is minus 1 on everything. Okay. Vertical asymptote at x equals h. What is h in this problem? -2. Okay, and then this is the moment where I want you to see what happened with this being an inverse. We flip the x and y for the asymptotes, just like we flip the x and y for the table, just like we flip the x and y for the equation, just like we flip the x and y for the graph. Okay, now the table is easy because we can cheat off our previous table. And domain and range is easy because we get to cheat off our previous domain and range, because the range is going to come up here and become this domain. That's not or equal to. That's not or equal to. It was just a complete and total like body reaction. I don't know what happened. And your domain will come down here and become your range. Okay, last thing we need to do is graph it. So I graph the asymptote first. X equals -2 is over here. -1.9, -3, -1.7, -2, -1, -1, 1, 0, 7, 1. Okay, what's my last thing I do? Cherry on top. What is it? Okay, we did every single thing you could possibly imagine, minus end behavior, which I don't want to do because it's gross for these. But we did everything you could possibly do for inverse of an exponential to a logarithm. Table, graph, equation, domain, range, asymptotes, AHK, steps, rewrite. That was a lot. That problem is probably longer than the whole rest of the classwork. So here's the next one, and this one's going to take us about, I don't know, 40 seconds. Okay, so let's do this first one. This is just a straight up log graph. There's no inverses involved. This is basically where I want to show you how much you need to do for full credit. So this is my sketch, basically. Okay, first thing I'm going to do over here is identify A, H, and K. In this problem, A is 1 in front, B, or H, B is actually 3. H is also 1, K is 2. So 1, 1, 2. All right, what do we need to know about logs? So the first thing we need to know is the vertical asymptote. Vertical asymptote at x equals h. Okay. Then you're going to sketch that in dashed. Okay, reminder from yesterday, locator point is not HK, because that's actually on the dash line. So you gotta bump it one over. So what would my locator point be? Perfect, 1 plus 1 comma 2. So instead of being 1, 2, it's 2, 2. And you can literally go to HK and then bump yourself one box over. Okay, last thing, literally, last thing. A is a positive number, so that means you're going to come from the bottom. So come along the asymptote from the bottom. Make sure to hit the locator point and then curve off. I don't care about the height or steepness of your curve. I care that you come along the asymptote, hit the locator point, and curve off. And that's it. Really, these are like hyperbolas, you just sketch them. If you want to use a graphing calculator, I showed you how, but this is plenty for me. Okay. All right, last thing. These are Guinan circle problems. Just wanted to do notes for those. Log to exponential form. Okay. Guinan circle. Start with a 5. 5 to the x equals 125. So start with the 5 to the power of x equals 125. Okay, 125 is what? Yes, nice. 5 to the x equals 5 to the 3. Cancel, cancel. X equals 3. So, log problem, convert to a same base exponential. Okay, next one. 2 to the x equals 1/8. Okay, now I'm going to do this problem in 2 steps because it's confusing. Okay, but so what I'm going to do first is I'm going to make 2 to the x equals 1 over 2 to the third. So the first thing I'm going to do is just take that 8 and make it 2 to the third. And then I'm going to draw myself a little arrow because I'm going to bring this up to the numerator. 2 to the x equals 2 to the negative 3. If you need to do that, please do. If you don't, you can show it in one step. I don't care. Second to last one. 2 to the 0 equals x. 1 equals x. Nothing, no kind of equation needs to be solved there. X is already by itself. Okay, last one. Did you guys have the alien problem in your homework yet? Aliens counting on their fingers, something? No? Okay. So there's this problem in the homework where the aliens count on a certain base of log of how many fingers they have, or toes or something. I don't know. Anyway, how many fingers and toes do we have? How many fingers do you have? Yeah, 10, right? Hopefully. If things, what's moving. My horse bit my finger the other day and I thought it was coming up. So, anyway, don't hand feed, not a good idea. Create a monster, an apple monster. Anyway, giant 1,000-pound apple monster. Um, so you guys ever think about why we count in base 10? why when you move the digit over one spot, it's times 10, and it's not because 10 is friendly, it's literally because you have 10 fingers. Yeah, it's true. It's actually completely true. Back in the Babylonian times, they used to count in base 60. So every time you move over a spot, you wouldn't be moving over 10, you'd be moving over 60. It's called hexadecimal counting, hexadecimal base. Anyway, I had to take a history of mathematics class to be esteemed teacher. Base 10 is much easier. Okay, what am I getting at here? I'm getting at we have some logs where the base is missing. And that's because those are the most common. So just like plain old x is x to the 1, but we don't really write the 1, or 1x is just plain x, so we don't really write the 1. There's base of a log that is normal, and that is base 10. So whenever you have this spot, nothing's there, put a little baby 10 there. And the reason is because you have 10 fingers, and that's the most common one. So the most common one is base 10, and it also has its very own button on the calculator. This button is base 10 log. So you guys can actually go on the calculator for this one and just do log 6. Okay, now let's just practice what we learned about logs though real quick. So I'm still going to do the guide and circle because I want you to see what this means. It means 10 to the what is 6. You don't know how to solve that yet without a calculator. That's fine. But we could put 10 to the that. Oh, miracles upon miracles, it works. It's 6. So what's the moral of the story here? Plain log is log base 10. So we're just going to write ourselves a little note. Log equals log base 10. So anytime that you guys have a plain log with nobody there, just put a little baby 10. Why? Because you have 10 fingies.